Okay, let's go ahead and start the next one. Very similar. Number 4. So we have height of 15-year-old boys, normally distributed with a mean of 67.5. I'll put that, our mean slash median right there. And this time our standard deviation is 2.1. So I'm going to go up by 2.1 for each of these. So we're going to have 69.6. We're going to have 71.7. We're going to have 73.8. Okay. Then I'm also going to go down by 2.1 for my deviations below the mean. So we're going to go to 65.4, 63.3, and then 61.2. Alright, so there we go. What between what heights are 68% of the 15-year-old boys? Now these percentages you're seeing are going to correspond to the ones you're seeing up here. So we have between 65.4 and 69.6. You can say 65.4 to 69.6. Okay. Once again, 95%, that's going to correspond to the 2 standard deviations. Remember, this is 1, this is 2, and this is 3. So between the negative second and the positive second standard deviation is going to be 63.3 and 71.7. So from 63.3 to 71.7. Okay. And our third deviation, very similar. It's going to be between 61.2 and 73.8. Alright, that's it for number 5. Okay, let's continue on the other side. Next page. Number 5. Okay. Alright, so which dot plot displays the data set with a larger standard deviation? Remember, standard deviation is the spread. How spread out is the information. Okay. If you look here, this looks to be like the middle information, 40, and we have some all the way down here to 25, and we have something all the way up to 60. So this is pretty well spread out. Over here we have a mean probably right around here, and that's like the middle, and this goes down to 25, and this one only goes up to 50. So on the left side, you can see both of these are about the same. They both go about 25, but to the right, this one goes up to 50, while this one goes all the way up to 60. So this one right here makes it more spread out, which means this is going to have the larger standard deviation. Okay, so data set 1 will have the larger, mainly because of this. This is the only one that's different. Okay. Number 6, look at all these. Okay. We're going to determine the largest and the smallest standard deviation. We don't have to calculate this, but it's again just looking about how spread out are they. Or look at the middle number, if they're in least to greatest like they are now, and about how far away are all the other numbers. So these are pretty close, right? Only about one or two away. Okay, 1 to 2 away in each direction. Pretty close. Here, these are also only about 2 away, right? From 23 to 21, it's 2 away. From 23 to 25, it's 2 away. So this standard deviation is a little bit bigger. here, this is only going to be about 0.1 to 0.2 away, and this is 0.1 to 0.2 away on this side. So this is very small. 0.1 and 0.2, very small. Over here, that's going to be, 10 or 20 away. So the spread here is much bigger. 10 to 20 away in each direction. So that's very large. So I'm going to say my largest one is going to be data set D. Call it data D. And my smallest is going to be data C. And you can kind of tell because these are very small numbers and they're not going to be quite as spread out because they're smaller numbers. They're already close to each other the way it is. And these are already far away from each other the way it is. Okay, let's determine the R value. Remember, R stands for correlation coefficient. That's the correlation coefficient. Okay, that's what R stands for. First of all, we can say that this is definitely negative. Okay, it's going down, it's definitely negative. So there are points close to it, so it's not going to be any positives. 0 means there'd be points everywhere and there'd be no correlation. So the question you're left with, are these strongly correlated or just moderately? So you get to judge, are these pretty close to the line or are they kind of off the line a little bit? Okay, I would say they're not exactly on the line like they would be like right here. That'd be close to 1, so that's not happening. So I'm going to go with the negative 0.5. Okay. For slope, the next question, I'm going to calculate it. I'm going to pick 2 points not close to each other, but close to the line. So if you look at the line, the best fit, what 2 are closest to the line? Okay, probably right here and right here. So I'm going to estimate these. Okay, this is 1, 7. And let's say this is 9, 1.5. And I'll find the slope with those 2 coordinates. So we'll have the y's on top. 7 minus 1.5. And the x is on bottom. 1 minus 9. Okay, that will equal 5.5 divided by negative 8. And I'm going to put that slope in my calculator. So 5.5 divided by 8. Okay, about 0.687, round that up, 0.69. So negative 0.69. My y-intercept, I'm just going to estimate that by how it looks. I'm going to estimate, follow my line of best fit, and it looks like about 8.4. I'm going to go with 8.4. So I'm going to say my b is about 8.4. So I have an m, I have a b. My equation is always mx plus b, so that'll give me an equation of y equals negative 0.69x and plus 8.4. There's my line of best fit.